I'll be going through the least squares regression line and the least squares regression equation. Just making sure I'm recording. Yep. So in the last video, we had a look at the Pearson's correlation coefficient, which looked at the strength of a relationship. So now we're actually going to look at actually fitting a line. And in the past, you've probably called this a line of best fit. So what I mean by that, if I had a scatter plot and you had you put in all your points and then you would put a line of best fit in, which you would have done in your earlier years of high school. So again, that's a little bit inaccurate. So what we're going to do is let the calculator fit a least squares regression line to our data. So a least squares regression line. What is happening here, why it's called a least squares regression line, if you've got a scatter plot like this, what it's doing, what your calculator is doing very amazingly with like amazing accuracy, is it's moving this line. I don't know. Oh, I can move it. It's moving this line to reduce the squared amount of each of the distances from each point to the line. What I mean by that, and why it's called a square, is it's reducing the distances for all of these lines. So if I add up all those distances, what your calculator is doing is reducing that amount to the lowest possible amount by adjusting that line. Why it's called a square, because what it's actually doing is it's adding up the square of each of those values. So that's why it's called a square. So that's just a background of where the name is coming from. You don't actually have to do this process. Your calculator is going to do it all for you, which is amazing. And you do it in the exact same place that you get your Pearson's correlation coefficient. So the steps are very easy. So the regression line can be put in really easy with your calculator, and we're interested in the equation, the regression equation. So the equation of a least squares regression line is y equals a plus bx, where a is your intercept of the response variable axes, or the y variable axes, and b is your slope, right? And we write the actual variable names in there. So this is going to be our response variable, whatever that is, equals a, whatever the a value is, plus the slope times the explanatory variable. Okay, this will make sense in a second. Let's do an example. So how to determine and graph the least squares regression line using the class pad. So I've just taken this straight out of your textbook. So the following data shows per capita the income in thousands of dollars and the carbon dioxide emissions in tons of 11 countries. Determine the graph and the equation of the least squares regression line that will enable CO2 emissions to be predicted from income. All right, so if you go to your calculator and you open up statistics, you're going to first of all, before I get too carried away, we need to work out what is the EV and what is the RV. So in this case, our EV is the income and our RV is the CO2 emissions. So EV goes in list 1 always, that's our X, and the RV is list 2, which is our Y. Okay, so back to our calculator. I have already put in the data in here. So this is our income and that is our CO2 emissions. So the steps are as follows to get the equation of our line. So, and it's the exact same way as we get the R value, so the Pearson's correlation coefficient. So we go, the steps are calc, regression, linear, and again, I haven't changed the list name of X or Y, so I can just leave that as is. And I don't need to change anything else, and I just press OK. And just make sure, again, I told you in the last video to make sure that this is in the equation A plus BX. If your equation is in this format, AX plus B, please change it to A plus BX. Once you set it, it won't change unless you reset your calculator or change the batteries. So once it's set, it's done. All right, so, and then we just need to note the value of A and B. So A there, we'll say 2 decimal places. So we'll go, so 1.39 is A, B is 0.42, and I'm going to note down the R because I think that we need that later on. So that's 0.82. All right, so let's go back to the question so I can write down some stuff. All right, so determine and graph the equation of the least squares regression line. All right, so let's write down the equation before we get into the graph. So what I need you to do when you're first learning how to do this, what you're going to do, you're going to do this in 3 steps. So first step is you're going to write down the equation, which is up here, or you can write it down like this. So RV is equal to A plus B times EV. Remember that RV is your response variable and EV is your explanatory variable. And I'll just write down our values over here that we got from the calculator. So 1.39, B was 1.42, and R was 0.82. Okay, so I've written down my rule. The next step is I'm going to sub in my A and my B values, and I'm going to write everything down the same. I might just change this color. So 1.39 plus 0.42 times EV. Right, so I've done that. Now, the third step is I need to change the response variable and the explanatory variable positions in the equation to what the actual variables were in the question, because at the moment there's nothing in the question that talks about explanatory variables and response variables. The question is clearly talking about capita income and also the CO2 tons. So I want to change the RV in my equation to the RV here. So whatever you put in list 2 will go here, and whatever you put in list 1 is written here. So it's like giving a mathematical sentence that you're explaining this equation by. So I'm going to just call that CO2 tons. So, it's carbon dioxide emissions. So I'm going to call it maybe emissions. Might be a nice way to label that one. So emissions. So carbon dioxide emissions, which is measured in tonnes. So emissions is given by 1.39 plus 0.42. And then in the brackets, I've got the income, which is measured in thousands of dollars. So I would write income there. All right. So because there's a little bracket there, that just means times. So 0.42 times the income. All right. So that is my equation of the line that is going to come from the least squares regression line of this set of data. So like I said, when you're first starting to do this, finding the equation, do it in 3 steps. So put in your data. Once you've got your A and your B value, write down the rule like this. So it's basically your it's a linear, the equation of a linear line basically. And then you're going to sub in your values of A and B, and then you sub in your variable names. Just make sure you have these around the right way. So remember, this is what you put in list 2, and this is what you put in list 1. All right, you'll get better with this over time, so don't stress if you get a little bit muddled up at the beginning. So we've done this one. We've written the equation in terms of the variables with the coefficients given. We haven't done 3 significant figures because I didn't read the question. Whoopsie, we've done 2 decimal places instead. 2 decimal places. This is why you should always read the question. And I'll come back and I'll do this part, and I'll show you how to look at the scatter plot and how the regression equation appears, or the regression line appears on your graph. But let's have a look. I don't know why these are all A. I'm pretty sure that should be B and C. But anyway, whoops. All right, so determine and write down the value of the correlation coefficient. So we were having a look at correlation coefficient, R, to 3 sig figs. I've changed that to 2 decimal places. So for C, I wrote it over here, so 0.82. And remember, R, or the Pearson's correlation coefficient, tells us about the strength of the relationship. Now, this is positive because there's no minus sign there, and it's above 0.75, so it's a strong positive relationship or correlation, whatever you want to say. All right, so in this part of the textbook, you might be asked to also comment on the strength of the relationship, which you should know how to do from the last video. All right, so I've got my equation. There's my equation there. So I've done that part. Again, do it in 3 steps just while you're learning. Once you get really good at it, you can go straight into this. That's completely fine. And what you call this, like you could have called that CO2, as long as it's matching the question is fine. All right, let's go back to our calculator. So this is where I found the A and B, the same places where you find the R. It's really good practice just to jot down those numbers to as many decimal places at this step, just so you've got them down and you don't have to keep going back and finding them. If I press OK, automatically I should have a lovely little scatter plot appear, and it's got your least squares regression line already in. So it shows you what it should look like on your scatter plot there. All right. If when you click out of that, if it doesn't show, if you just press that up there, it should graph. So I'll repeat that again. If once you go find the A, the B value and the R, if your graph doesn't appear, just press this button here, which will graph your scatter plot and the least squares regression line. Okay, so I'll repeat those steps again. So once you have your data, establish what is the EV and what is the RV. So we put EV in list 1, we put RV in list 2. Then once you've entered the data, we go calc, regression, linear. We don't need to change anything in this section at all. We go OK. And then up here, we need to note down our A value, our B value. So our A value is the intercept, so where it crosses the y-intercept. The B value is the slope or the gradient of the line, the steepness of the line. And the R value talks about the strength of the relationship. So once you've got those copied down, then you're going, and you've been asked for the equation of the line, write down this here. So RV equals A plus B times EV. Then you sub in your A value and your B value. So remember, our A is our slope. Our A is our intercept and our B is the slope of the line. Be careful to take the sign in front. So if there is a minus in front of either of those numbers, make sure it appears in here. And then your EV. And then the last step, just write in whatever the variable name was for RV. So that's what you put in list 2. And whatever your variable name was in list 1. Which in this case was income. So this is like a little math sentence that says emissions is found by 1.39 plus 0.42 times the income of the country, and that will make a prediction for emissions. And then we had a look at the strength of the relationship. So just a quick note on a recap on A and B with your linear stuff, which we would like to go through properly at some stage this year, but we'll see how we go for time. So if you've got a line, so the A and B there, so the A is your intercept and your B value, did not mean to do that, just deleted half of my things. So that was your A, the intercept, and your B value is your slope, so your rise over run. You've probably done that many times before when you're doing linear graphs in grade 8, grade 9, grade 10. Just remember that your slope, so this is a positive slope, so this is a positive B, and then if you've got a negative B, you're going down the hill. So again, this little guy would be your A value, so your intercept, and then your slope here is the fall over the run. So it would be a negative B for this one. Have a go at this exercise. Hopefully you don't have any trouble. Like I said, when you're first getting your head around the equation, do it in 3 steps. It's probably easier that way. And just reach out to your teacher if you're having a bit of a hard time. All right.